The America just shocked the world with what they're building. On January 13, 2026, the U.S. Secretary of War Pete Hegseth publicly declared a sweeping transformation of the Pentagon's technology enterprise that placed artificial intelligence, autonomous systems, drones, and hypersonic technologies at the very center of U.S. defense strategy. His words were stark. That old era ends today. We are done running a peacetime science fair while our potential adversaries are running a wartime arms race. These aren't just slogans. They come attached to new memorandums that reorganize how the U.S. buys and fields AI systems, with an emphasis on rapid integration over traditional bureaucratic delays. At the heart of this shift is a clear prioritization. Get capable AI into the hands of warfighters faster than ever before. The message from the Department of War is unmistakable. AI isn't a future concept. It's happening now, and it's being built into real systems with real deadlines and real budgets. Consider how fast this transformation is being resourced. The Pentagon is not only investing in prototyping, it's committing hundreds of millions of dollars in contracts to leading AI firms to accelerate battlefield AI adoption. In 2025, some of the nation's biggest AI developers, including Anthropic, Google, OpenAI, and xAI, received contract funding of up to $200 million each to help integrate advanced models into defense systems focused on planning, decision support, and operational readiness. This level of funding reflects a pivot. The U.S. military now sees AI as indispensable to command decision-making and tactical superiority, not just an accessory. But what does that look like on the ground? Major defense primes, such as L3Harris, are prototyping scalable autonomy architectures that could coordinate hundreds or even thousands of autonomous assets simultaneously. For example, the L3Harris amorphous software platform is being designed to manage uncrewed aerial systems, sea vessels, and ground robots, not from a single command station, but by letting swarms self-coordinate based on shared mission rules. This approach reduces mission risk if a central controller fails, because the swarm maintains cohesion and continues to operate autonomously. That capability is the kind of transformation that changes how wars are fought. Swarm autonomy means a small number of human supervisors can, in theory, direct thousands of drones or robotic vehicles, making traditional force massing obsolete and democratic fielding of force dynamics more feasible in contested environments. Another major frontier is AI-powered cybersecurity. U.S. national labs such as Pacific Northwest National Laboratory are demonstrating groundbreaking AI systems capable of simulating cyber attacks and identifying vulnerabilities that would take human teams weeks or months to find. One such system, developed with assistance from Anthropic's models and advanced simulation tools, promises to automatically gauge and patch weaknesses in critical infrastructure code, representing a new paradigm in defensive AI. This is not sci-fi. This is happening now, with national labs directly pushing offensive and defensive AI methods toward real-world deployment. A nuance few mainstream reports focus on is how much AI ethics, trust, and reliability engineering matter in this context. The Department of Defense and its research partners routinely fund research into AI assurance frameworks that can ensure systems behave predictably even under chaotic battlefield conditions. Emerging academic work suggests traditional approaches to technology evaluation, such as technology readiness levels, are being rethought entirely to account for AI's unique needs. Contextual learning, unpredictable emergent behavior, and dynamic decision cycles that outstrip human reaction times. This is the invisible infrastructure that eventually allows autonomous systems to be certified and deployed at scale without catastrophic failures, a critical requirement if commanders are going to trust AI in time-sensitive, life-or-death scenarios. In parallel with all of this, industry and academia are wrestling with one of the core paradoxes of military AI: speed versus control. Faster systems can make better split-second decisions, but autonomy that is too unconstrained can create unpredictability and unintended escalations. That's why Pentagon initiatives fund behavior risk evaluation tools and watchdog systems that monitor AI behavior in real time, flagging anomalous actions for human review before those actions precipitate dangerous outcomes. AI is not just changing machines, it's also changing human roles. Wearable heads-up displays and augmented reality systems that overlay tactical data directly into a soldier's field of view are transition. Technology between pure human decision-making and machine-aided warfighting. These headsets fuse LiDAR, computer vision, and real-time AI prediction so that a combatant sees a dynamically updated battlefield map with threats, friendlies, navigational cues, and mission cues all integrated. Some of these technologies have already won prototype contracts, and the civilian spin-offs like instant training overlays for complex repairs are why Silicon Valley and venture capital firms are eagerly partnering with defense contractors. One of the most important and least publicized trends you should understand is how industrial collaboration is shaping military AI. Defense firms such as Palantir and Enduro are forming consortiums to tackle challenges that extend beyond a single contract or platform. These partnerships aim to create a seamless development pipeline from edge sensors to enterprise command centers, combining data analytics, robust AI models, and real-time decision support into cohesive systems. This means the entire AI ecosystem, not just isolated prototypes, is being engineered for use at scale across the force, from intelligence fusion to autonomous targeting. Some of these efforts are not just about offense or autonomous weapons, they are about decision superiority. AI tools are now part of programs that manage logistics and supply chains, battlefield predictions, and ISR, intelligence, surveillance, reconnaissance, offering commanders a real-time, AI-enriched picture of global threats and opportunities. These tools are critical because warfighting in the AI era is less about shooting first and more about seeing first, deciding first, and acting first. And that brings us back to a core strategic risk. As these capabilities grow, so does the potential for catastrophic misinterpretation. Faster decisions carry less human oversight, and when autonomous systems can suspend judgment for milliseconds, those milliseconds matter in geopolitical crises. That's why policy debates about AI in military contexts continue. Advanced frameworks for trustworthy, accountable AI are being pursued not just in labs, but in the corridors of Congress and within doctrine offices across joint services. But for now, the story is this. The United States is not just researching AI, it is actively building, testing, and fielding systems that integrate autonomy into every domain of defense. From cyber infra to autonomous fleets, from wearable AR to enterprise-scale command systems, this broad suite of technologies is redefining what force projection looks like.